Alright, hello again. This is Jeff Scott of Blackhawk Technical College, and for the 152-143 Beginning Java Programming class, or Intro to Java Programming, whatever it's called, I've been going over the material that's in the book. I've already done the 11 PowerPoint lectures for chapters 1 through 11, and I've gone through chapter 2 in the book and wrote a couple programs for you. Now I am into chapter 3, which, as you can see here, is on decision structures. So we'll talk quite a bit about the if statement and its different variants, talk about the logical operators, talk about how you compare strings because a straight if doesn't work. We'll continue to explore variable declaration and scope. We'll talk about what's called the conditional or ternary operator, also called the question mark colon operator. Talk quite a bit about the switch statement. I've already shown you the system.out.printf and string.format, so we'll take a look at those. And some common errors at the end. So, as mentioned here down toward the bottom of page 111, the if statement is used to create a decision structure. So, depending on how you're going, okay, you might have something that looks like this. And I'm making this up, so it doesn't really mean much of anything. Let's go down here. So let's say I'm going down a road. Okay, going down a road. All right. But in this case, I'll be going up the road, and I get to right here. And maybe now the road forks off into this direction. All right. So I've got my choice. I can continue down the road here, or I can just stop. It's kind of like an if statement. Now, the author shows something in the book, but I want to write it because he shows it non-code based. So let's say that I come in here and I say this. Int age equals 21. All right, then we come down here and we say if age greater than or equal to 18, and we're going to create a Boolean variable called able to vote. So able to vote equals true. All right. Now, that's a simple if statement. There's no else that goes with it. It's just a simple if. So if your age is greater than or equal to 18, let's assume we've also created a Boolean variable here. And it's called able to vote. And we initialized it to false. So, if you're greater than or equal to 18, your age, you are able to vote, so we set it to true. There's no sense here in saying this, else able to vote equal false. We don't really have to do that. We could, it wouldn't hurt anything. But we don't have to do that because we've already set it up here, up there. But let's say we didn't set it. So we just did this. And if this is really reminiscent of what we've been working on in the last couple chapters, we probably wouldn't set the age, but we'd come in here and either use an input dialog, or we would use a keyboard object, and we'd actually read in the age. But here I just hard-coded it in. So here's the two different variants. Okay. What if we don't know your age? So, what if the age that is in here just seems really weird? In other words, this isn't a great example for an if and an else if, but in this case, you're either greater than or equal to 18, or you're not greater than or equal to 18. Remember that to the computer there's no gray area. So if I change this from able to vote, let's say to able to marry. And I realize it's not, I'm just, again, I'm doing this off the top of my head. So what we're saying here is if you were over 18 or over, you're able to marry. Otherwise, you're not able to marry. I realize that's not how it works in real life. People marry at younger than 18. But you get the idea. All right? So we could say, if your age is greater than or equal to that, all right? Otherwise, we could say, else if age else if parental permission equal true, then able to marry is also going to be equal to true. So you've got a note from your mom or your dad, let's say if you are if you happen to be less than 18. Else able to marry equal false. So we'll create in here yet another variable that's called parental permission. So Boolean parental permission. We're just going to assume that that's true. So if you're greater than or equal to 18, you don't need any parental permission. All right? But if you get down to an else, well, this wasn't true, so you're not greater than or equal to 18 because you've gotten down to the else. So if you get down to the else, which means you're less than 18, if parental permission is true, you can also marry. But if you're not greater than or equal to 18, and if you don't have parental permission, then you can't marry. Now that's kind of a convoluted, silly example that I just came up with off the top of my head, but ideally at least, you get the idea when we start to talk about the if statement, what's in here. Because the examples that the author gives are like this. Is it cold outside? If it is, wear a coat. Or maybe you want to do more than that. Wear a coat, wear a hat, wear gloves. So hopefully what you noticed is when I gave you the example, that what comes after the if must be in parentheses, and it must be a Boolean expression. So it's something that the computer must be able to align or resign itself to being true or false. To use this, you quite often use what are called relational operators, and they're shown right here. They're the greater than operator, the less than operator, the greater than or equal to operator, the less than or equal to operator, the equal to operator, and please note it's a double equal sign, and the not equal to operator, which is an exclamation point with an equal sign, sometimes called bat equals or bang equals. So here's some examples. And they're just doing something simple with X and Y, but I did other things for you just so you could see what was going on in the examples that I just gave. So here's an example, like it says, let's look at an example of the if statement. If your sales are greater than $50,000, you get a $500 bonus. Well, in this case, they have a program in here where you put in 3 test scores. Then you add the 3 test scores together and divide by 3 to get the average. You need to have these in parentheses because if you didn't, you'd get a wrong answer. And it tells you the average. And then you're saying here, and I wish the author somehow put this on 1 page rather than 2, but if the average is greater than 95, you say that's a great score. But notice there's no else. So for instance, in this example, you got an 82, a 76, and a 91, which meant your average was an 83. But it doesn't say that was a great score. On the other hand, if you've got a 92, a 98, and a 100, your average is 96.67, so it says that is a great score. So again, we've gone over this stuff in much of the code that's like it in the JavaScript class. Now, if you are in this class and you have not taken the JavaScript class, you maybe be a little bit behind the 8 ball, so to speak. All right, so it's going to be imperative for everybody in this class that you read the chapters that are in the book. I'm providing a lot of PowerPoint and book in program lectures, but still, there's nothing that sometimes beats sitting down yourself, going through the stuff that's in the book, and if you've got time, even keying in some of the examples. That's the best way to learn. All right, here's some more examples. If hours are greater than 40, overtime is true. We're going to do something similar to that in the program we're going to do in a little bit. If value is less than 32, print out invalid number. Now, when you write this, it's not mandatory, if it's just one line like this, that you use curly braces, but you may or may not have noticed when I did it, I used curly braces. I think that's a good idea, and I put my curlies each on their own line. I like doing that. You may or may not agree. I mean, you can take this to an extreme, and I showed you this in some of the examples we've gone through. So there'd be my begin. There's my end. In fact, I even like to put sometimes blank spaces like that in here. So you might think that's a little bit extreme as far as what I'm putting in here with a lot of comments, and maybe it is. All right, but I can look at that and know exactly what's going on, where my curlies go, what goes with what, etc. So if you think that that is too much, too many comments, too busy a code, then don't do it that way. Don't put the comments here. All right? If it helps you, then put them there. I've said this to you before, that during the first year of the program at Blackhawk, you should be concentrating on understandability of code, understanding yourself, and write it in a way that you think others can understand it. It's much more important than seeing how little bit of code that you can write. All right, so no semicolon at the end of an if. If you do, you'll get an error message. In fact, you may not even get an error message, but the program will work correctly. You can have multiple lines, and there you need the curly braces. Again, if it's only one line, you don't need it, even though I put it in at all times. All right. You can compare characters. You can have anything you want in here in the parentheses, as long as it comes down to a true or a false. That's all that matters. I already mentioned the if-else with you. With an if-else, either that statement or block will be executed, or that statement or block will be executed. One of those must be executed. Only one can be executed. So notice what we say here. We tell you to put in two numbers. If the second number was 0, you say you can't divide by 0. So it says run the program again. Otherwise, it does the division. It's a very, what you're doing in there is some very, very simplistic validation. And they show an example here on page 123 of what it would look like if you ran it. You can have an if statement within an if statement. So when you think about it, what I could do, all right, is I could, and the example I wrote before isn't going to work very well for this. So, whoops, for that example, I'm not going to use it now. All right, so I'm going to get rid of this example that I put in here before. So, all right, I'm going to say int x equals 21, int y equals 17. And again, these don't mean anything. I'm making up all these values, int z. So if I come in here and say if, and I could do it just like this, if x is greater than or equal to 21 and y is less than or equal to 18, z equals 1. Else, z equals negative 1. So you can see by looking at this that z is either going to be 1 or it's going to be negative 1. Well, in this case, is x greater than or equal to 21? Yes, it is. Is y less than or equal to 18? Yes, it is. So since it says this is an and both conditions are met, we're going to do this. If we had done this, now, is x greater than or equal to 21? Yes. Is y less than or equal to 18? No, it's not. So we're going to do this. When you have this in here, this is a relational operator. This is an and, which says both of them must be true. Okay? Now, let's say we did it the opposite way. So let's say what we did. I'm just going to put this in here. I'm going to change this to a less than. All right? And we'll change that back. Okay. The way that Java works, it's like many other programming languages. It does what's called short circuit evaluation. So it checks this one. It says, is x less than or equal to 21? Let's change that to a less than. So it says, is x less than 21? Well, it's not. When you use an and like this, since both sides of the equation must be true, and since the first side is already false, it doesn't even check the second side. It doesn't have to make this check because it already knows since that's false, the whole thing's false, and you're going to do this. All right? If you do an or, which is two pipe sides, if I do this, it does short circuit evaluation also. It says, is x less than or equal to 21? Yes, it is. So it never checks this because it doesn't have to. It's just going to go in and do that and skip that. So with what I've just shown you is you've got and, you've got or, and you've got not. Those are your three different relational operators where you're able to compare things. Okay? So what does this have to do with nested ifs? Well, let's take a look. I'm going to leave all that stuff there. In fact, I'm going to grab, let me just hit enter a few times here. I could have written this like this. So instead of the way I've written it right here, I could have done this. I could have said, if x is less than or equal to 21, then I could have come in here and said, if y is less than or equal to 18, then done this. So see what I'm doing is I'm putting an if within an if, and these are called nested if statements. All right? So I only make this check if this check is true. So if x is not less than or equal to 21, I never come into here, I just go right to here. If x is less than or equal to 21, and it is, then I come in here and check y. So I could combine them on the same line, or I could use an if within an if, which is a nested if. And that's what the author is talking about in here. So notice, to see whether or not you qualify for a loan, your salary must be greater than or equal to $30,000 a year. You do not get into this if right here unless that if is true. So if your salary is not greater than or equal to $30,000, it just says you must make that to apply. But if it is, you must also be on the job greater than or equal to 2 years. So if both this condition is true and this condition is true, then you say you qualify for the loan. If the first condition is true but the second one is false, you don't qualify for the loan. And if the first one is false, you skip the whole body and you just come in there and say that they don't qualify. Again, if you have any questions on this stuff, you're going to have to read through it, and maybe read through it a few times before it makes some sense to you. Alright, so they go on quite a ways in here and talk about a lot, but it's the same stuff. Great example here in this spotlight section that Gaddis puts in It's working with grades. So if your grade's 90 or above, it's an A, 80 or above, it's a B, 70 or above, it's a C, 60 or above, it's a D, below 60 is an F. But he does it like this. He shows you it in flowchart form, which is what this is, and then he writes the code. And I've shown an example similar to this in another lecture. But I went from the top down. He goes from the bottom up. So if your score is less than or equal to 60, it's an F. Otherwise, if it's less than or equal to 70, it's a D. Otherwise, if it's less than or equal to 80, it's a C. Otherwise, if it's less than or equal to 90, it's a B. Otherwise, it's an A. He writes it, and it looks pretty ugly like that. They have the ifs on a line by themselves, so they could have all been done with else ifs also. There's a lot of ways this could be written. But he hasn't talked about the else if yet. I have, but he has not. So here he rewrote it using the else if, and it looks much cleaner. Remember, only one of these conditions that are in here can be true. So either this is true, or this is true, or this is true, or this is true. And if none of those first four conditions are true, you do this. So that final else that's in there is a catch-all. There can only be one else. There can be as many else ifs as you want, and the else at the bottom is a catch-all, so it's optional. If you don't want to put it in, you don't have to. And he runs through this. And he talks about using the trailing else to catch errors, which is what I just mentioned to you. So again, F, D, C, B, A, invalid score. So if you put in something that's not within the range, so it's either greater than 100 or it's less than 0, that's how it'll be handled. It says you never have to use the else, if, else structure. However, if you've got a lot of if-elses, it can grow long and hard to understand, and indentation can be a real pain in the butt. So, you know, whether you use nested ifs or you use the else if is up to you, it's up to the situation, and it's up to the clarity that you have. All right? For logical operators, I already mentioned and, or, and not to you. And somewhere in here they show a truth table. So when you're working with and, if they're both true, the whole thing is true. Otherwise, it doesn't matter. If either one is false or they're both false, the whole thing's false. They talk about the short circuit evaluation. I already showed you that. All right, they go through an and example in here, maybe better than the one I showed you. There is an or. Here's the truth table for an or. Only if they're both false is the whole thing false. Otherwise, the whole thing is true. Again, you use short circuiting in here, and there's an or example right there. Finally, the last one is not, which is also known as the inverter or the inversion operator. So not true is false, and not false is true. If you have a complex expression that has both and or and not, so if you have all of these in the same expression, and let's say you do and you don't use parentheses, then the way that this works is you do the ands first. Sorry, you do the nots first. Then you do the ands, then you do the ors. The most restrictive, the least restrictive, and what's in the middle. So if I've got a bunch of these and I'm not using parentheses, I'll do all my nots first, then I'll do my ands, then I'll do my ors. I can always circumvent that by using parentheses. And the author shows you several examples in here. Typically, if you want to see if something is within range, you use an and statement. If you want to see if something is out of range, you use an or statement. And again, all this stuff that I'm telling you like that, all of that stuff, those are generalizations. But normally they hold true. All right, so that's if you're comparing remember, the Java primitive variables. We talked about those primitives before. Those being the whole number, byte, short, int, and long. The ones that can hold a decimal place, float, and double. And the ones that are not numeric, char and boolean. But now let's talk about strings. If I've got two different strings and I do this, even if both of these hold mark, this is still going to be false. Because once I do this, and once I do this, I have two different places in memory. One for name 1, one for name 2. Even if they hold the same value, they're two different places in memory. And what this does is it says, does this point to the same thing? So even if they were both Mark or both Mary, this would be false, always, the way it's written. So you can't compare strings with a double equal sign. Instead, when you compare strings, you've got to do it like this. So you'll notice here that name 1 and name 2, all right, they both have Mark in there, even though they're different variables. So if I say if name 1 dot equals name 2, it will say name 1 and name 2 are the same. All right. Well, here, Mark and Mary, it's 1 and 3. Well, they have different values, so it'll print out they're not the same. That's what we should get. Mark and Mark are the same. Mark and Mary are not the same. Okay. There's also a compare to, and with a compare to, if it returns 0, the two are the same thing. If the first one is less than the second one, all right, it'll give you a negative number. If the first one is greater than the second one, it'll give you a positive number. So Mary is greater than Mark because Y is greater than K. And this is called a lexicographical comparison that it does right there. Okay. Sometimes you want to do this and you don't want to care about the string. So you can do an equals, but you can use ignore case. So it won't matter if you use uppercase, lowercase, or some variant of the two. All right, let's talk a little bit more about declaration and scope. Any variable that I create inside of main here, so first name and last name, this variable here and this variable here are only known within the main function. But as we go on, we're going to, or the main method, as we go on, we're going to create other methods. So first name and last name wouldn't be known in those methods. Not only that, those methods could have their own first name and last name. But what you'll see later is if we create variables in here, so in between lines 9 and 10, so they're inside of the class but outside of any method, then they're global to the class. Any method in the class can use them. So you're going to see that as we go on. All right, next we've got the conditional operator that looks like this. It's also called the ternary operator and the question mark colon operator. So what I'm going to do is before we go into switch here, I'm going to write you a quick ternary operator example. All right, let's say I've got two numbers, int num1, and I'm going to set that equal to 37. Int num2, and I'm going to set that equal to 43. Again, I'm making these numbers up. Int max. And then I come through here and I say if num1 is greater than or equal to num2. I'll be in there, sorry. So if it's greater than or equal to it, max equals num1. Else max equals num2. And there's absolutely nothing wrong. That's a perfectly fine way of writing that. Not a problem whatsoever. None. It's just fine. But if I want to take all of this stuff, which is what? 1, 2, 3, 4, 5, 6, 7, 8 lines of code, I can replace it with this. So, replace with this. I can say max equals num1 greater than or equal to num2. If that's true, question mark, num1. If that's false, colon, num2. And I forgot the 1 there, sorry. This one line right there will replace all of these lines right here. What it does is it says compare num1 and num2. If num1 is greater than or equal to num2, you do what comes after the question mark. So you take num1 and you assign it to max. If num1 is not greater than or equal to num2, you do what comes after the colon, which says take num2 and assign it to max. So I'll leave that up there for a second, but again, that one line of code. And sometimes people say, well, what if it's a more complex thing? This right here, what comes here, could be another question mark colon, if we wanted to do it. Now, a lot of people like writing like that, and a lot of other people find writing stuff like what I'm showing you right now to be very confusing. If you're the latter, if you find that to be confusing, don't do it. All right? And if it makes sense to you, take advantage of it. All right. The next thing that's discussed in here is the switch statement. And the switch is kind of like a nicer way of writing an if. It works very well for some things and not for others. So we're assuming right here that we've got a variable that's called month. And it's going to have a value, we're going to assume, between 1 and 12. We're only showing 1 through 3 here, but let's assume it can contain 1 through 12. All right? So we're not going to show the rest, but we'd have April, May, June, July, August, September, October, November, December in here also. All right? So this is like an if. This is like here saying if month equal 1, system.out.println January, else if num equal 2, system.out.println February, else if month equal 3, system.out.println March, and in the case we have here, we'd say else system.out.println error invalid month. So this is a shortcut. We need the word break here because if we left off these breaks, let's say we left all of month. This one won't matter one way or the other. But let's say we left off all of these break statements and the month was 1. It would still print this, but since there wasn't a break, it would also print this, and since there wasn't a break, it would also print this, and since there wasn't a break, it would also print this, which would be very confusing. So break says when you hit that, get out of the switch. All right? And that's the explanation that's given here on 156 and 157. And they give a demo on how it can be used. There's a lot of different ways that you can use this. Some people love to use the switch and try to use it whenever they can. Other people find it more confusing and use it only when almost forced to. You know, I think that it can lead to code that is much easier to understand. Okay, notice you can also use chars in there. So ints and chars will work fine. You can even use strings. That's relatively new in the Java programming language. It used to be that you had to use either a char or an int type. You cannot use in there, I don't believe, a double or a float. All right, now the system.out.println and the string.format I've already shown you. Okay, we've already looked at that in earlier programs. So I showed you this. This %f is a placeholder, which means that after the comma, this must be of type float. And if you just put %f, it'll do sales, but it'll do it to 6 decimal places. If you say %.2f, that would have changed it to 12345.67. Okay. But like I said, we've gone through those before. They go through a big, long, hairy-winded thing in here on format specifier syntax, so I'll let you read that at your own leisure and precision. You can put a minimum field width in there, so there's a lot of different stuff you can do with this. It's fairly common to use this because you can format things in the way you want them formatted. They talk a little bit about flags in here. It says there's several flags you can use with this to pad numbers, left justify, add commas, etc. So again, I'll let you read that as you get time and have the desire to do so. All right, there's also a string.format that I'm getting to. So we're going to see that. So formatting string arguments. So rather than system.out.printf, all right, which is fine to use, and you can use that virtually all the time, there is also a string.format that you can use, and it works in a similar way. Is there an advantage of one as opposed to the other? Not particularly. All right, so again, look at them, see if one makes more sense to you than the other. You like the verbiage or whatever of one more than the other. and that's the one you should use. All right? So as always, please read through these common errors. I don't want to take the time to go through them with you, but there's some good stuff in here, and we'll go over, for Chapter 3, Chapter 2, we're going to go over 2 programs and do them as a class. For Chapter 3, we're going to go over 1 program at the end of the chapter as a class, and then I'm going to assign another one for you to work with and work on. So that'll be your first actual assignment that you'll be doing on your own. That's all I have.